Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 869, which was rated for Division 2. So I believe like today's problem set was like any other day. It was pretty balanced for the first three problems. Although I didn't see much summations on the third problem, I don't know why, but I believe that problem was not very difficult. And as usual, I was not able to solve the fourth problem during the contest. Although I made many long attempts on this particular problem, I tried my best to solve this problem. And if you read the problem statement for an expert level or for an upper specialist, I believe this problem was solvable, but unfortunately I couldn't do it during the contest. So anyways, let us start with the first problem discussion. So the first problem is politics, and basically there is some information that has been given to us, and there will be n members and k opinions, right? So what we have to do is, during each discussion they say that if more members agree than disagree, and all the members who disagree have to leave the club, right? So for each opinion, anybody can agree or disagree, right? Now if more members disagree than agree, and all the members who have agreed leave the club, right? So if there is a tie, all the members leave the club. Now, what we have to do is we have to maximize the number of members remaining after the meeting, right? So this is our goal. Now there is one more very important thing, that as a president we have to be in the in the whole club till the end, right? So you will find that this is the very important thing that will really help you to solve this particular problem, right? This is the only line that will help you to solve this problem, that you are the president or the first member in the group, in the given in people. The first member is the president, and he or she has to stay in the club till the end, right? Now we have to maximize the number of members remaining after the meeting, and at each we already know this particular information. So at each step we are allowed to remove any members from on our own, right? So basically I'll explain you this all this information with the help of a test case. So I believe like that's all the information that the question gives us. Now let us discuss the test case. So here the plus sign, you will see that the input is given as a string of plus minus. So the plus sign is denoting that that particular person has given a yes or an agreement to that particular opinion, right? So let me just write it down for you so that it is easier to understand. So there will be n people and there will be k topics to talk about, or k opinions, right? So for example, if this is the first person, this is P1, this is P2, let us discuss the first sample test case. And this is, let's say, opinion 1 and opinion 2, right? So this is plus, that means the person agrees on opinion 1 as well as the person 1 agrees on opinion 2. This is plus and this is minus, that means the person 2 agrees on opinion 1 but he or she disagrees on opinion 2, right? So what we essentially have to do is at the end we have to make sure that we are present in the in the final output. And also we have to maximize the number of people that are present in the final remaining what do we say, club, right? So there are of certain things that you need to remember about this problem. So P1 should always be there, always be there, always be present, let us say, right? So this is the first important condition, right? So we can never remove person 1 from the whole list. So if you observe that let's say we have taken the third test case. So this is plus 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 plus, and we have plus minus minus plus, and we have plus plus minus plus, and we have plus minus plus and plus, and the last one is plus 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 plus, right? You would observe that all of them agree on the first. So now you would observe that all of them agree on the first opinion, right? So we keep all of them, right? We remove none of them. Now let us say we are talking about the second opinion. There are some people who disagree with the second opinion, right? But our goal is to preserve this particular person, that is P1, because he is the the president of the club, so he should always be there. So our goal will be to preserve P1. So all the places that do not have a matching character will get removed. So let us say this particular position will have to be removed, right? This particular position will have to be removed. Why? Because these particular characters do not match the opinion of P1. Now, if we move on to the next opinion, we will see that this particular position does not match P1. So we will have to remove this. Again, at the end, at the final opinion, P1 and the last person, P5 are matching, right? So they will both remain at the end. So essentially, you would observe at the end, like the whole point of this particular discussion is all the strings that are similar to P1 will be remaining at the end, and all the strings that differ in at least one position from P1 will be removed from the final answer, right? So our goal is to just find the number of strings that are similar to P1 or the first string that we have been given into the input, right? So the whole problem statement is just reduced to this particular part, and you needed to observe that only the people who have the same opinion as P1 will remain at the end, right? So let us see. I would say like the name politics was very apt for this particular problem, because at the end all the members who have similar opinion to the president will only be remaining, and all the other members will be removed. So let me just show you the code for this particular problem. What I have done is I have taken two integers n and k, and I have created a vector of strings of size n, and I have taken input in it. Now I initialize my answer with 1, and I am traversing through all the strings from 1 to less than n. Right. So if v of I is equals to v of 0, I'll add 1 to my answer. Otherwise, I'll do nothing. So at the end, I can just print my answer. So this particular thing is a Boolean statement. So if it is true, it will return 1, otherwise it will return false. So it will return 1 only if the current string is matching to the input string or the first string, right? So in this case, I return my answer. So this would be the solution of the first problem. Now let us discuss the second problem, which is indivisible. So this particular problem says that we have to form a permutation of size n such that when we take the sum of every subarray of size greater than or equals to 2, then the sum should not be divisible by the size of the subarray, right? So let's explain you. Oh, there are no sample test cases, so we'll just discuss it directly. So let's say we have a1, a2, a3, a4 and a5, right? So you will observe that so what we essentially have to do is we have to consider all subarrays. So this is a subarray of size 2, then subarray of size 3, then subarray of size 4, and all the subarrays like these. Then if we consider a subarray of size 4, for example, a2 plus a3 plus a4 plus a5, it is a subarray of size 4, right? If we divide it by 4, this particular value should not be divisible by 4, right? So it should be true that any subarray, the sum of the subarray is not divisible by its size for every subarray which has a size greater than or equals to 2. So it does not apply to size a subarray of size 1, right? So the size of the subarray should be greater than 1. Now by just reading this particular point, our very first observation is that the numbers have to be in alternating sequence. That is, the first number, if the first number is odd, then the second number has to be even, right? So this is always true. Why? Because it becomes a subarray of size 2. Now for a subarray of size 2, we don't want the sum to be even. So if we add even plus even, it will be even. If we add odd plus odd, it will be odd. So obviously the only remaining option that we have is adding odd plus even, and that should be odd, right? So from here we have found out that the permutation will have one character odd and one character even, right? So it should be alternating in sequence. Now one more observation: if you try for any size for n, like for example n is 3, n is 5, for any odd n, you will find that the sum of all the values in this case, and let me just take 7 also. So this is 6 and it is divisible by 3. So 6 mod 3 is equals to 0, right? This is 5, 4, 9, 10, 15, and 15 mod 5 is equals to 0, right? In this case also, this is 6, 4, 10, and this is 5, and this is 5. So this is also 10, and 7 plus 1, 8. So this is 28, right? So 28 mod 7 is equals to 0, right? You will observe for each value of n that is odd, the answer will always be 0, because if you add all the values together for any n, the value would be divisible by the number n itself, right? So we have found out that the answer does not exist for any n that is odd. Obviously, there would be an exception to this particular case when n is odd, right? So we have to consider this also. So let us talk about a case when the value of n is even. So I wanted to tell you one thing about this problem. All problems that are similar to these, there is no definite way of solving these problems. Today, even I submitted a wrong solution on this particular problem in my first attempt. But later on, I implemented a checker function which helped me to check whether the permutation that I'm creating is a valid permutation or not. Right. So when I found out a way which was approved by the checker function, only then I submitted my code second time, and as in the second approach, it was approved. So what you essentially have to do is you will have to make the numbers like this. For example, n is equals to 6. You will have to write the numbers like 2, 1. Then the next even number is 4. Then the next odd number is 3. Then 6 and then 5. Right. So this would be the only way to write the permutation. Two things that we did by observation was that we have to write one odd number and one even number. Right. And the second thing was any permutation of size n which is odd cannot have an answer, right? So from these two information, how did we reach this particular position? So the first thing is n should be alternating, right? So I could have written a sequence like this: 1 2 3 4 5 and 6, right? But in that case, this is a permutation, right? So this is a permutation of size n is equals to odd. So in this case, n is 5 and n is odd also, right? So the sum of this particular value would be some number. Let's say it was 15 here, and 15 minus 5 would be equals to 0, right? So this way the answer will not exist. So what I can instead do is I can just reverse the positions 2 1 4 3 and 6 5. So now you will see that if I make a subarray of size 5, the values 1 to 5 are not present here. Again, if I make a subarray of size 5, all the values from 1 to 5 are not present here, right? So this way I am able to improve my answer. I didn't want all the 5 consecutive numbers to be present together, right? Similarly, if the size of the permutation was 8, right? So if I consider, let me just erase this. So if I consider this particular part, this particular sum will be some value, let's say x, and x divided by x mod 7 will be equals to 0, right? But if I just switch these positions 2 1 4 3 6 5 and 8 7, right? So this way the first 7 values will not have the sum from 1 to 7, and the last 7 values will not have the sum from 1 to 7. So this way I am able to improve my answer, keeping mind in both of the conditions, right? So the correct way to solve this problem would be to write the first odd or even number, then the first odd number, and then the second even number, and the second odd number, like this, right? So let me just show you the code for this particular problem now, how I implemented it during the contest. So you will see that in this particular case, what I have done is this was my checker function where I was checking whether the sum is divisible by the current size of the current subarray or not, right? So although I just commented out it later on when I found the correct answer. So what I have done is I have taken a if n is equals to 1, I just directly print 1 and return. If n is odd, I just print -1 and return. Otherwise, I just initialize two variables, I will be equals to 2 and j will be equals to 1. So since I am printing the values in pairs, I have to run a value till n by 2, right? So by x minus minus, I just print the first value, even value, and the second odd value. I increment both of them by 2, and I just at the end I just print new line. So this would be the solution of the second problem. Now moving on to the third problem. So for this particular problem, I would have passed all the pretests in the first attempt only. But what happened was when I submitted my first solution, so I missed at one place. I just mistyped something. Instead of n plus 1, I wrote n, and because of it failed on pretest 3. And then I changed my approach and I submitted a wrong solution again. And then I submitted the third attempt with my original idea. So the only difference was I mistyped at one place, right? So let me quickly summarize what this problem says. So this particular problem says that a sequence is called almost increasing if it does not contain these three characters, right? So these three should be x, y, and z. So if this is array of I, this should be array of I plus 1, and this should be array of I plus 2, right? And they follow this particular pattern. There should be no three consecutive characters in an array such that they follow this particular pattern. Only then a sequence is called almost increasing, right? So now they have given us some queries in the form of LNR. And they have asked us what is the size of the longest subsequence such that it is a almost increasing subsequence. So obviously, if we have been given a subarray from L to R, what we would want is we would want to remove all those characters which are causing the current
subsequence to be non almost increasing, right? If we remove all those problem causing places, then our final sequence will be almost increasing. So this is our idea. So let us discuss some sample test cases first. So this is the first sample test case. So what we have here is 1, 2, 4, 3, 3, 5, 6, 2, 1. So you see at this particular position, the next element is less than or equals to the first element, and the third element is less than or equals to the second element. Similarly, a similar thing could be found at this particular position. So these are the only two positions which might cause a problem to the current subsequence being a almost increasing subsequence, right? So what we have to do is, what do we essentially have to do is, whenever we find a subsequence such that, for example, if I want to find this particular in this particular range, what is the size of the maximum subsequence, right? So I would obviously want to remove this particular problem causing range, right? So how do I fix this particular problem causing range? In this particular case, even if I remove any one of those elements, the remaining would be 335. Let's say we have removed the first character. So this would be the size of the maximum subsequence. But I can also remove the second character and it would be 435. It is also correct. And I can also remove the third character. It would be 435 and it is also correct. So let me discuss a case where the element that we remove actually changes our final answer, right? So let me just write 10, 9, 1, 5, 1. So this is a test case that I was thinking during the contest. So in this particular test case, if we consider the range 1 to 5, so we are considering the whole range, right? So what if I remove this particular character, right? Then the remaining values would be 10, 9, 5 and 1, right? Again, this is a problem causing range, right? So I will have to remove this particular character. Then the remaining values will be 10, 9 and 1. So this is also a problem causing range. So I'll have to remove any one of those 9 or 1. So again, let us assume that we remove 9 and then we'll be having 10 or 1, 1, right? So you see, in this particular case, the size of the final subsequence is 2. But let us try to remove some other character now. So if we have 10, 9, 1, 5 and 1, right? So this was the range causing the problem. If we decide to remove the middle character of the range, then the final subsequence will be 10, 1, 5 and 1. So in this case, you see, there is no elements or there is no range, which is a problem causing range. So the final size of the subsequence will be 4. So you will observe that whenever there exists a problem causing range of 3 elements, of 3 consecutive elements x, y and z, it is always optimal to remove the middle element, right? So like this information only matters to us because if we have some ranges, for example, some problem causing ranges consisting of the elements x, y and z, then even if we remove one of them, right, we will be able to remove the whole range, and that is why the number of elements that we will have to remove will be equal to the number of consecutive elements x, y and z in that particular range, right? So if in the initial element, if in the initial array, for example, in this particular array, the array was 1, 2, 4, 3, 3, 5, 6, 2, 1. We discussed that this is a problem causing range from 4, 3, 3 and 6 to 1 is also a problem causing range. So if we talk about the whole array, I can just remove these two characters 4 and 2. Then the final sub array would be 1, 2, 4, 3, 5, 6, 1. So if you see that this particular final subsequence will not have any problem causing range or problem causing x, y and z elements, right? So the final, since there were only 2 problem causing ranges, we will have to remove 2 elements from our final subsequence. So this is the main idea. Now one more thing that we have to think of is, whenever, for example, if this is a problem causing range, right, because the x, y and z, because they follow this particular order, right? But if I am only considering my range, my final subarray range till here, then the third element will never be included. So I will only have to include the range problem causing ranges which started from at least here, right? At least from this position, only then these three characters can form the problem causing range. But if, for example, in this particular case, the range was starting from here and this particular element could never complete its problem causing range. So if I am given a range L to R, I need to find the number of elements which start a problem causing range in the range L to R minus 2, right? So the starting point should be from L to R minus 2. So what I can essentially do is I can just mark the starting points of problem causing range. So if I have some variables x, y and z in this particular manner, I can store what are the positions of x, right? I can mark them as 1, right? Once I get all those values, I can calculate the prefix sums and I can find all the range. For example, if I have the prefix array like this, I can find all the elements in the range R minus 2 minus prefix of L minus 1, right? So this would be the number of elements I will have to remove, right? So I believe like this is all about this particular problem. I know that this problem might be a little bit complex, so let me just quickly summarize what I just said. So like by observation, we concluded that if there are three elements x, y and z, it is always optimal to remove the middle element y, right? Now if you have multiple elements x1, y1, z1 and x2, y2, z2 like this in my array, so for each of these problem causing ranges, I can remove the middle element y1 and y2 respectively, and the number of elements I want to remove will be equals to the number of these problem causing ranges that I have. So if I am given a range L to R, I essentially have to find what are the how many starting points are there in the range L to R minus 2 such that it contains x1, x2 and so on respectively, right? So all the elements should be present in the range L to R minus 2. Why I am R minus 2? Because if the starting point is at R minus 2, only then it will be considered. If the starting point is at R minus 1, let's say 4, 3, 3. If this is the right range R, this is R minus 1, then the third element of this particular range will never be included into our current subarray range, right? So we don't have to consider this particular element. Only when the 4 is present at least R minus 2 and this is R minus 1, this is R. So if the 4 is present at least 2 spaces backwards, only then it will be considered because the final element will be included in our answer, right? So let me just show you the code for this particular problem now. So the code is like pretty straightforward. What I've done is I've taken two variables n and q. So n is the number of variables and q is the number of queries. So I've created a vector of size n plus 1 and I've taken input array. So what I essentially do is for all positions from 1 to n plus 1, I just check whether the current if the I plus 2th index exists or not. If it exists, then dp of I will be equal to dp of I minus 1 plus I will have to check whether the current element will make my answer anywhere better or not, right? So I have named this particular array dp, but this is essentially the prefix sum vector. So if the current element was also a starting point, that means v of I is greater than or equal to v of I plus 1 and v of I plus 1 is greater than or equal to v of I plus 2. I'll add 1 to my answer, right? Otherwise, like in this particular case, when I plus 2 is not in the range, then I can just break. So I just go through all the queries, and if R minus 2 is less than L, then I can just directly print the size of the subarray that has been given to us in the input. Otherwise, I just print the size of the subarray minus all the elements that I have to remove. So all the elements that I have to remove will be dp of R minus 2 minus dp of L minus 1. Right. So this would be the solution of the third and the final problem of today's problem discussion. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to this channel. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, please do consider subscribing to this channel. Until the next video drops, keep coding, stay safe, bye bye.